Well, hi, good morning, and thank you for joining me in my shop. Today is December 10th, and I have in front of me a nice little radio here. Don't know anything about it. I know as much about this as you know about it, looking at it. It's got some wonky knobs on it. So, my objective here is to figure out if this radio works or can be made to work, and whether it's worth maybe putting a little investment into it, fix it up a little bit. Northern Electric Company Limited, Montreal, Canada. And this is model. Looks like 1554. Model 1554. Made in Canada, in Montreal. Antenna wire hanging out. This is probably the original cord here. Somebody's done away with the plug. Some antenna connections here. How come this is bent out like this? It would appear that the chassis is sticking out a little bit too. Let's see how you're supposed to hold this in. A little information on the bottom. It's being held in just by its knobs. Tube locations. What do we got here? 12SA7, 12SK7, 12SQ7, 35Z5, and 35L6. 35L6. Usually this would be a 50, and not a 35, because you add these up. So that's 35, 35, and 35, basically. What would that be? 70, it'd be 105, a little short of 115. And just some patent information here. Guarantee. Oh, it has a guarantee. The guarantee under which this radio sold does not provide for free installation. It must be returned to the dealer for free service within the guarantee period, and dealers are required to make a service charge for all outside calls. Northern Electric Company. Okay, let's pull these knobs off and the guts are going to come right out. These certainly aren't the right knobs. Nice try, whoever did it. At least the three similar knobs. There we go. Oh my gosh, this got a short wave band. Oh, wouldn't have imagined that. Short wave band down here. Oh, an interesting little display. Couldn't see it because the plastic is so bad. Look at that. And this is a little bit familiar to me. Okay, trimmers on top of the coils. Light bulb is missing. Has a field coil type speaker, electromagnetic speaker. Has all its tubes. Pretty dirty. Pretty dirty. Oh, the dirt is really piled up just back in here because this has been kind of bent back and open. So the dirt's been going in. It's really filthy. That suggests to me nobody's fooling around with this guy yet. Let's flip him up. We'll take a peek underneath. How do you get this off? Looks like it's just shoved on. No, what's holding this on? I think it's just folded over here. Really? That's it? Yeah, that's it. Wow. Bob, I'm telling you, we can save 3 screws per radio if we just bend this plate. Okay, Bill. And obviously nobody's done a thing in here. So we have a lot of bad looking capacitors, all these wax ones. Last radio I did, the wax capacitors looked fantastic, and in fact the test I performed would suggest the quality of the capacitors indicated they were great. But these ones I don't think would pass. And a couple of adjustments under here. Three adjustments under here. The original filter capacitor. This doesn't look original, this one here. But it could be. I mean, it's got a nice space for it, so this could be original. This is a 450 volt. I can't. I don't see the size of it. This is probably original. Probably this is too, but who knows? So nothing more unusual about it, but a large high wattage resistor here. Looks like it's been hot. So my first question is, do I dare turn this thing on just the way it is? And I often do dare to turn these guys on just the way they are. So the missing plug is a little curious. Sometimes that indicates that somebody thought this radio should never be plugged in again. So they've taken the plug off as a kind of a message. Maybe they needed the plug for some other radio. So, wow, this is really awfully long amounts of bared off wire here. Okay, just going to go take a little break, and then we're going to fire this guy up carefully and see what happens. Okay, I think we're ready to go. I've got an antenna connected to the radio since it has no internal antenna. I think some tears in this. Oh yeah, the speaker's torn. Quite badly, in fact. Ooh, almost all the way through there. Ooh. Fingers off. Okay, so I've made a temporary, highly safe connection to the wire. It's plugged into my bench supply here. The bench supply is not directly into an outlet. It's going through a number of things. It's going through a little switch panel up here. Just in case you haven't watched any of my videos before, I'll just explain this quickly. This will this will arm the system. And this selector switch, if I push it down, the power that comes to here, that eventually comes to the radio, is passing through these incandescent light bulbs on the way to restrict the amount of power coming to the device under test. If I flip the switch up, then it's a direct connection to the Darlington nuclear plant, which isn't too far from here, right to reactor number 3. So now what to expect here? There's no light bulb here. It'd be better if there was a light bulb in there. And okay, off switch. This must be the band selector switch. I'm going to put these knobs back on. I think these knobs came from an automobile radio myself. Oops. These knobs have really very energetic knobs here. Okay, so first test will be with the radio switched off. And we're going to find out if the off switch really does turn it off. So the radio's off. I'm going to apply power. So you're going to see probably this meter pop up down here. It's not a precision meter by any means. The precision is actually in this box here. 118 volts. Nothing has happened, so I'm sure the switch is good. That's a good thing to know. Okay, just giving myself a moment to realize why I shouldn't do this. I think we're okay. So what to expect? So one possibility is the radio's going to hum like crazy. I'm just going to turn on, big hum, that's the end of that. Another possibility is it's not going to hum so loudly. We can keep it operating and find out if it actually tunes stuff. If any one of the tubes has an open filament, none of them will light. And the light bulb, what we can expect in these light bulbs, I'm going to unscrew this one. This one light bulb. When you first turn the set on, the tubes are cold and the current flows through the heaters quickly. Or a lot of current flows, not quickly. A lot of current flows. The light will come on. So click on the power, light comes on, and then it will quickly go down. and that's as the heaters heat up, they draw less and less power. It happens fairly quick. Down it goes. The power draw on the radio will stay low, the light will stay low, until the tubes warm up enough that they themselves start conducting and operating. Then the power draw on the radio will increase and the light will come up a little bit. You may or may not be able to see it. Just depends on how much power this thing is drawing. If there's a short in here, something really seriously wrong, then when I hit the switch, the light will come on bright, just stay bright. Now, I can judge this with my eyes. You can't with the camera. The camera just is no good at doing this. I see a lot better with my eyes than you see with the camera when it comes to this. Okay, we want the volume to be up a little bit, not too high. And we want to be on what we think is the broadcast band. So I think flipping it this way should be broadcast. We can check that because that's right here. Guess what? It's shortwave that way. Okay, broadcast band. The reason for picking the broadcast band is it's more likely to make noise and hiss and for me to recognize that it's operating. Okay, I think we're ready here. Everybody should just step back a little bit. That's a good idea. Here we go. So lights come on quite bright. It's dimming down slowly. See, it's dropping almost all the voltage. There's only 50 volts left for the radio, so it'll take a long time to heat up like this. But this already indicates all the tubes have conducting filaments in them. These radios normally operate as low as 90 volts, much lower than that, and a lot of them need at least 100 to make them go. So what I'm going to do is I'm going to do two things here. I want the radio to operate with a little more voltage than this, but I still want the bulb in just in case something goes. So I'm just going to crank it up here with this control. 80 volts, 82. Should be able to hear something. Can you hear it? No, that's the cat. That's a cat playing in the background there. Yeah, he's very busy. Quite intent. I hear the radio. Very garbled. So what we're going to do is we're going to turn it off. We're going to turn this way down to below the usual 120 setting. We're going to send, I flip the switch here so we're no longer going through the light bulb. Straight to, actually it's a Bruce nuclear plant that we're hooking up to. So this is ready to go. Flip it on. Again, no drama because there's no light. Tubes are warming up. Voltage is 92. That's low. We're going to go a little higher once it gets going. Go up a little higher. We really want it up at least over 100, I would think. 104 volts, that's enough. So you can tell that's a person's voice, eh? Can't understand what he's saying though. So I think that's called intermodulation distortion. It's not distortion in the usual sense. Intermodulation means the signal you're listening to is being modulated accidentally by something. I think the hum is modulating the sound, and that's why you not only hear the hum, but you hear his voice. Sounds like he's from another planet. Let's tune around. What's the matter with the pointer? Capacitor's not moving either. String is there. So the capacitor is probably just stuck. Maybe I can help it out a bit. But you know what? I don't want to stick my fingers back there just yet. Look at how they've done the... So this capacitor frame is up on grommets. And there's a good chance that the voltage on the frame is different than the voltage on the chassis. And I don't want to find out the hard way. So I'm not going to poke around with that just now. But we did hear kind of a station coming in. We can hear the hum. I think that's probably all we can really do at this point anyway. Okay. Very good. We don't know why they cut the cord, the plug off, or took the plug off. They didn't cut it. Somebody took the. Oh, look at my tape job here. High security tape job. It's probably why electricians don't rely on masking tape for their work. Well, next step on this. Probably work on getting rid of the hum. That's usually the first thing you have to do with these radios, and I think that's the case with this one. So, to get rid of the hum means replacing this guy for sure, and probably this one. And it would be smart if we looked at the schematic before starting any of this kind of stuff. I don't know, should I be smart? I'll go talk to my cup of coffee for a few minutes about that. It's not always smart to be smart. Okay, why don't we start with this capacitor here. And so it's got this strap on it. It's screwed in very good. A lot of times these, it's a big screwdriver here. Wow, that ever come loose? I didn't think it was very tight. Must be loose by now. There we go. Out you come. Okay, so now see 3 wires, 2 well, they don't look red, but these would be 2 red ones and a black one coming out of there. Oh, another black one down here. Okay, so these are 3 red ones. They don't look very red. So this is a little unusual in that this big capacitor is here, and this one is here with 3 sections. So usually there's 2 sections in this thing that are in the power supply, and in one section, a smaller capacitor, in fact, that's used as a bypass on the output tube cathode resistor. But when you see another big capacitor here, you tend to think these are the power supply capacitors and this is the bypass one. So this looks awfully big. I mean, this is physically almost as big as this thing. I got to read the value on it. Maybe I can do it with this guy here. This is hidden right around behind here. Jeepers creepers. That was 8. That's what it is. It's 8. 8 microfarads. So it's a small. This is a very small one. So there's a field coil in the on the speaker. The field coil, from my experience, does most of the filtering, and the capacitors that are typically on either side in a pi arrangement are small, typically 6, 8, 10. So we see an 8 here. So now I don't know what to think. There's an 8 here, and I never did get the size of this thing. So we can cut this negative because for sure I'm going to replace this. Cut it and leave a lot of it out. Use that wire. So this is a 40-40-20. The 240s are 150 volt, so it's designed for this kind of radio, obviously. And the last one is 25 volt, and that's the bypass. That's the yellow one. Which one of these is the yellow one? And the other colors is supposedly red and blue. Red, blue, and yellow. Yeah. Okay. Yeah, I do think we need to look at the schematic though before we do too much more. In fact, I can see already this capacitor is connected to the same wire as this. So what somebody I think has done is they've augmented the capacitance in the radio by putting in a new capacitor in addition with the original old one, paralleling it in. I believe that's what they did. Yeah. Okay, I'm going to hunt down the schematic. We'll take a look. So this is the radio museum page for this radio, the 1554. And maybe you don't remember what the cabinet looks like, but it's not quite like this. This part looks the same, but this part is different over here. If we look at some of the other pictures that people have sent in, there's one like this. That's closer to what I've got here, but not quite the same. And I don't know, is there another one like this? This looks very close to what I've got. But this grid you can see here, this is not what's on the front of this radio. So what this means is they had the same chassis in a good number of different radios, which is very common, of course. So we'll take a look at the schematic here. Okay, let's rotate it. Here we are. Lots of writing down here. I'm not going to go through it right around. Here's something here. All voltage is read from common negative lead, wiring side of tubes shown. So a few things we want to look for right off the bat. Down here in the filter area, let me zoom a bit. We want to see what they're doing here. Look at this. They've got 3. That's a 0.03 microfarad. That's a very small small capacitor compared to these guys. 40 and 40. So they're large capacitors here. Usually this is an 8 and an 8. Or something of that sort, 10 and 10. When they have a field coil in here. Okay. This capacitor here is actually just across the power line. It's right across the power line. So it'll be a power line filter. And I think you might be able to say it gives the radio some access to earth ground through the electric system. There might be some truth in what I just said there. There's the output voltage written right here, 87. Wow, that's low. And here it should be much higher. I'm not sure what they're writing there. RD red yellow, red black. They're talking about the wires here. These are the wires that lead from under the chassis up to the speaker field coil and back. So they're trying to give you the colors there. These are part numbers, 50, 51. I didn't see a part list. So somewhere there's a part list. Did they write values up here? Somebody else has handwritten the values in up here. And a few other bits of information. Okay, I think we will want to look at the chassis connection. So this symbol is often used for chassis. It almost looks like it's soldered to the chassis here. A 0.2 microfarad is a fair size capacitor, so I'm pretty sure, yes, that's what this is. This connection's a little odd. What's going on here? So it's going up to pin 1 on this tube. So this tube is probably a metal tube, or should be a metal tube, and pin 1 will tie to the metal can of the tube. So it's just like the chassis, if you like, and so they've hooked it up to the chassis. And this will quell, like you can't leave the metal shell floating here. It'll become an antenna transmitting into the tube. I don't know, this is an audio thing. I don't know. But yeah, that's it. Okay, what else can we spot in here that's of interest? There's two diodes inside the detector, and they're both tied together. So it's one big diode here. Volume control has a capacitor on the output, which is very normal, and we have an AVC. Here we are. So see this 2.2 megohm. It's almost always the same size resistor stuck in these radios. So this marks the AVC circuit, and on this side, very high impedance going into grids. Very typical. Here's some more voltages. 87, 87. 87 is very popular in this radio. 87 and 82. 80. Look at this is a little unusual. 87 volts on the screen, 82 on the plate. So it's not common for the plate to have a lower voltage than the screen. And if we look out here, there's no. So this is probably a hum coil, humbucking coil right here. What does that say? It would look like it says 170 watts, but I don't think this is 170 watts output. There's the IF frequency, very odd number, 463. That's really odd. 465 would make more sense. Why did they pick 463? You know, a couple of numbers up and down here doesn't make a lot of difference, but for some reason that's what they've picked. The dial will be set up with this in mind, and the dial pointer. 463. And all this data, which I'm not going to read right now. Realigning details. Okay. The issue at hand was the capacitor sizes, and there they are. Big. I'll put 47s in here that I have. And this one here. No, I just read this wrong. No, I didn't. I read it right. We should find this one and change it pretty soon, because it's right across the power line. In some radios, this capacitor, in effect, is ahead of the switch, sitting here. So in some of these radios, you plug them in, and you're energizing a capacitor whether you know it or not. And the problem is that capacitor is right on the power line. If the capacitor should fail, you know, it's here in Ontario, there'd be Niagara Falls pushing on it and 3 nuclear plants pushing on it. I don't think it's going to survive well. So it's worth making sure that this is a good new capacitor, very unlikely to short. That's the bottom line. Let's take a look at how they've done the light. So one of the problems in these radios is finding a voltage to operate the light. Other radios have a transformer in them, power transformer, and they can have a winding that usually powers the heaters and powers any lights, and it's a simple matter. But in this one, because these heaters are all in series, there is no easily available voltage to run a light bulb. 46. No, that's the part number, 46. They're not saying what kind of light it is. But oddly enough, it's probably a 47. But that's the number for the resistor. So how are they doing it here? So the light is connected. So you see right here. Right here. What the heck is going on? So because this is all turned around, I'm having trouble processing it in my head. But let's just, in plain English, there's a tap on the heater. Now in most of these diagrams, they show the tap right in the middle. The tap is not in the middle of the heater. This heater's got 35 volts dropping across it. If you stuck the tap in the middle, you'd get 15, 17 volts. So the tap is actually off to the side, specially designed to produce the right voltage to run this light, and even take into account the current flow through the light. This is all arranged. This is why a lot of repair guys will say, oh my god, the light is burned out, we got to replace this right away, because it's an integral part of what's going on in the heater here. There's also some belief that this light assists with the inrush current. When you turn on the radio, there's a rush of current into the heaters. I'm not so sure about that one myself. So you should really stick a light in there. I wish they would tell me what it is, but you know what? It's going to be in the parts list, and I don't think I have access to the parts list. But you can guess. This is a 47 light bulb. Okay, and putting in the wrong light bulb here is a little different than putting in the wrong light bulb in a transformer radio. In a transformer radio, you could put in a 44 or a 47. They're all 6, 7, 8, 6.3 volt bulbs or whatever. No problem. The amount of current going through the bulb, so what? It's just changes the load on the power transformer slightly. But in this case, you put in the wrong bulb. The bulb may want to take twice as much current. It's pulling it through the heater. And it's probably not wise to do anything here other than the bulb that they've asked for. And certainly I've got LED bulbs here. No. You can't stick an LED bulb in here. Again, if you have a transformer based radio, yeah, stick in your LED bulb, 6-volt bulb. But okay, enough talk about all that. I'll go ahead now. I'll change these two capacitors, just these two. And I'll cut that other one out. I don't an 8. Why is an 8 in there? Oh, let's look at the bypass on the yeah. So out of the cathode, there should be a resistor. Here it is, 230 ohms, right here, and then bypassing it is a capacitor, 20 microfarads. Now the 20 should be coming from the 3-part capacitor I've already pulled out of the radio, but there's another capacitor, 8. Where's an 8 fit in here? I don't know. Now sometimes in these diagrams they'll show electrolytic capacitors in a special way, but these don't seem to be showing this way. So we can't just look at the diagram and spot if there's an 8 floating around. But I don't know, where would an 8 even go? It's got to be involved in the power supply. So I really think somebody stuck that 8 in there. It's probably what they had in their junk box, and they stuck it in the hopes to quell a bit of hum. And I don't think it worked out all that well. And now my eye has just drifted over here to all these coils for no good reason. I'm looking at them. I'll have to take a peek at the antenna arrangement while we're looking here. So we have a wire antenna coming in, going through a small capacitor, driving the primary of this transformer, driving the primary of this one also, and then coming down and taking off. This is probably the oscillator. Yeah, these are probably the oscillator coils down here. You're in this switching here, as you're probably switching between this and this. And it looks like the antenna always feeds both primaries all the time. Got a capacitor here to somewhat tune this, I guess. I'm not sure why the capacitor is there. Then how's it get to the grid? So we'll go to the grid because it's easier to work back. So the first grid in the tube is going to be hooked up to the oscillator. That's the normal thing. This is probably oscillator output here. This is probably the tuning capacitor, one part, and this is the other part up here. It's the only capacitor with an arrow drawn through it like that. See, this one's also adjustable. I'm drawing the arrow here. This is a trimmer. So okay, so and this will be a this is normally a screen grid. You could think of it that way, but in this case they're probably using this as a plate, in fact. And so this becomes a little oscillator triode happening in here. And because it's oscillating, it affects the entire electron stream going through the tube. And consequently, the local oscillator is impressed or mixed with the signal coming in from the antenna. So let's go here. This is the grid that will be connected to the antenna, or you can call it the signal grid. And this, I can't really read what that says. Probably 1 megohm is just all that says. Large resistor. So the antenna signal will be coming through this capacitor. From here things get a little complicated because of the switches. Did we see a note that says switches showing in something or other position? I didn't see such a note. This switch actually is a double throw, like it whoosh, whoosh, back and forth. In the actual radio, it's a rotating switch. And I think we're going to have some trouble tracing this all through, right back to the antenna, but basically the output of these two transformers is connected after being switched properly to the grid here. Okay, no surprises. Less than 0.5 ohms. One of the things these radios are susceptible to, especially if they're hooked up to an outdoor antenna, which was the common thing back in the day, is lightning effects. Not exactly a lightning bolt hitting the antenna, but a lightning anywhere in the area could set up a voltage in here that would burn out one of these coils. Obviously a direct lightning hit would do the trick too. So it's not uncommon for these radios to have a blown antenna coil. Anything else I need to see here before it's too late? I can always come back and look again. Let's just check these tube types. So 35, 12, 12, 12, and the output tube. Why is it? Oh, the rectifier tube's over here. So the rectifier here. So there we are. So this 47 ohm. I can't read that, but it's going to be a high wattage resistor. Is the one that's compensating for the fact that they didn't put a 50 L6 in here. I wonder why. You could drop a 50 in here and you wouldn't need this resistor cooking the back of your radio. It's got to be a good reason. Maybe they had an overage of this particular tube in their warehouse and they had to consume them in a radio. They got a good deal from the tube manufacturer. I don't know. No doubt it was a thoughtful decision. I just don't know what the thoughts were. Okay, we'll carry on with the work and we'll try the radio. So I'll just show you what I've picked for the replacements. So for the bypass, it's this little guy. This is a 50 volt, 22 microfarad capacitor, a little tiny thing. Wow. And then these two are going to replace the two sections in here. And these are 160 volt 47 microfarad capacitors. That should do the trick. I'm going to install those. So what I do to make this work as simple as possible is I preserve the wires going to the old capacitor, trim them off, and then I'm going to attach the wires right up close to the capacitor here, like so. And then I don't have that solves a lot of problems with doing this. The support for this capacitor will come from the negative lead being soldered down here. That'll hold them in place quite nicely. Oh, this wire is not as long as I thought. Yeah, this is probably going to break off while I'm doing this. Maybe in this case, this isn't the wisest idea. Yeah, I don't know. I think I've ruined this wire. Okay, so what I was going to do, and so proudly show you how I make things easy. No, it's not going to happen here. This, I ruined the insulation on this wire, tugging it through, so we're going to get rid of it. The point where my phone rings and then I can't remember what I was doing when I come back in. So I'm going to put the clip on there. To mark where it came from. So I'm going to have to try to stick this down in here now. One of the problems is I got to cover this. Not a big problem, but you can't have these positive power supply leads exposed in a radio like this. It's not a good idea. So we'll just pick how about blue. Okay, well this is going to be a quick thing, but now it's not going to be a quick thing. Okay, we're sizing it up. Looks just fine. This leaves the last wire here, and this is long enough to come over. Good. So I think I'll do that second. I think what I'll do first is I'm going to do the ground connection first. Just get that out of the way. Maybe you shouldn't say ground. In North America, we have a bad practice of using the word ground. I should say B minus is where this is going. To where it's trying to go, anyway. Okay, so you don't have to watch me struggle away here. I'm going to solder these guys up. And I was just going to say, oh my gosh, I don't remember where the capacitor goes. I've got a clip right there, so I cannot forget. Let's move this guy over here. Let's get this guy down there. Okay, I'll carry on and get this done. Okay, I've got them soldered in. I'm just looking now to make sure I haven't made a mistake here. All looks good. Okay, so now we're going to try the radio again. We'll see what happens now. Somehow I have a special personal skill for getting these kinds of things backwards, but I'm pretty sure I didn't in this case. What I'm talking about is putting the electrolytic capacitor in backwards. Somehow I managed to do that fairly regularly. So, this is where the dim bulbs really play an important role. You're fooling around with the power supply. You make a mistake, it's significant. Talking about making a mistake. Look at this situation here. Okay. Still have an antenna hooked up, external antenna outside, connected. Okay, let's give it a go here. Switch is off. Power's on through the bulbs. Okay, switch on. Now, if the bulbs come on really bright and stay that way, I put the capacitors in backwards, but we don't think that's going to happen. The light is dulling down, although you probably can't see it. All is good. I didn't put a light in here. I should have put a light in there. So we're running with all of 50, 60 volts here. And screw in the other light bulb. This will raise the voltage right up to 91, 100. I should hear it. Not a sound. Not a sound. Uh-oh. Uh-oh, that's not good. We're at 94 volts and not hearing a thing. Oh boy. Uh-oh, uh-oh, uh-oh. Quadruple low. Oh. Let's put it back on there. Not a thing, not a thing. Oh. 93. Well, we're going to push it up over 100, but we should be hearing something anyway at this point, so something's wrong. Did I smell something burning? Something is burning. She's burning, Jim. There's smoke coming out of this. What happened? Who smoked? Okay, quick, get your thermal viewer going. Okay, I have to run. I'm just going to leave the camera going. You gotta run and get it back. quick while whatever's hot stays hot. You have to turn it back on again. Okay, viewer's going. Okay, so maybe you can see something really hot. Now, this is tricky to know what you're seeing here. I have to use a blocking technique. Maybe a piece of paper. This'll do. This'll do. Okay. The field of view on this camera is gigantic. So I'm covering it there. One of these capacitors got hot. Ooh, I think it might be this. There's not a lot of heat left in anything now. What is that? What is that spot? There's some spot in here that's really hot. Just to be sure. Put your finger through the speaker there, Jim. Well, I have to turn this on again and see what is smoking. There's a lot of stuff buried way down in here. Is it the capacitors they just put in? I can't imagine that. There's no sound coming out of the radio. Jim, you fool! Did you put these in backward? Did you make a short? No. I'm looking really hard for evidence of something burning, but the only thing that looked burnt is this guy here. And that's bound to get warm anyway. Okay, we're going to run it again. We're going to run it once more. We don't have to run it with very high voltage. We'll run it low. Put the dim bulbs in too. Okay, this is going to get hot really fast. Whatever it is will get hot really fast. So it's very hard to tell what this camera is seeing. So I'm going to hit the power just briefly here. Did I get? Yeah, there's power on the radio. It's not a lot of power. Okay, so the one thing that's standing out is this resistor here. See my finger going across it. So here at 60 volts. The actual temperature of that resistor is 40, almost 40 already. This guy here. Let me do the blocking thing to be absolutely sure it's the resistor that we're looking at. Okay, I'm just going to cover it. Yeah, you can see that. You can see that I'm covering it. So why is this resistor cooking? Is it cooking because there's something wrong with it? No, it's most likely cooking because I made a mistake when I soldered these things in, and I haven't discovered my mistake yet. And we're going to leave it at that. For today, I'm done for today. Okay, I'm not panicking over this. I'm sure I'll be able to sort it out, and it'll probably be something either embarrassing or interesting, one of those two. So thanks a lot for watching to this point, and we'll just carry on tomorrow and smoke some more parts. Sounds like a plan. See ya.